Hello everyone, and welcome to today's session. In this video, we'll explore how to set up a .NET application that integrates with groq endpoints, allowing for data streaming without dependencies. This project demonstrates a streamlined approach to building and deploying a .NET application capable of handling real-time responses with an AI-driven suggestion engine. To start, I've created a GitHub repository to house this project. We're aiming to build a solution that queries the groq endpoint and processes results seamlessly. To achieve this, I'll use an application I've called Groqlet. This is a .NET-based app designed to interact directly with groq, an HTTP client that processes requests and retrieves responses. Let's dive into the coding environment, here using Visual Studio Code. We'll begin by cloning the repository and configuring it for .NET development. To streamline our setup, we'll use the .NET CLI and set up a minimal Web API project. Here's where the .NET Web API provides a robust base for our app's backend, with minimal overhead. In the terminal, we can run a dry run command, allowing us to preview the files the CLI will create and configure. This is essential for understanding the structure of the application and managing dependencies effectively. With the files configured, we proceed with a test build and run. This verifies that our setup is working correctly before we add more complex functionality. By running .NET Run, we confirm that the application compiles successfully, and we can access our intended web link. Let's now discuss version control. I recommend setting up a .gitignore file at this stage, which helps exclude unnecessary files, like binaries, from the repository. To manage commits and updates easily, we use GitHub's integrated extension within VS Code, where we can commit and push changes without switching applications. Using the GitHub extension in VS Code simplifies the entire lifecycle of coding, committing, reviewing, and pushing updates to GitHub. This approach reduces context switching, fosters collaboration, and provides a powerful set of tools to maintain a smooth, efficient workflow directly within the VS Code environment. For a streamlined workflow, I've set up a debug launch task that automates building and launching the application in a single step. This setup is especially useful for handling frequent testing as we make incremental changes, minimizing repetitive steps so we can stay focused on development. To enhance debugging, I'm setting a breakpoint and testing an endpoint using the REST client extension, which allows us to send HTTP requests directly from within VS Code. Once the code hits the breakpoint, we can verify the output and inspect variables in real time. This allows us to closely monitor the flow of data and logic, ensuring everything is functioning as expected. Next, we incorporate an AI component into our project. I've added code from a separate repository, which leverages prompt engineering to enable reasoning, observation, and contextual thought processes within our application. With this functionality, the Groqlet can suggest the next book to read based on user input. This setup is the starting point for integrating advanced AI capabilities, where the application uses prompt-based interactions to produce a tailored response. For our front-end setup, I'm using a combination of htmx, an event source to achieve real-time data streaming from the .NET backend. Event source creates a persistent connection to the server, allowing our app to retrieve live updates from the groq API endpoint continuously and asynchronously. Additionally, by using the htmx framework, we simplify our front-end development significantly. htmx enables us to manage dynamic content with minimal JavaScript by binding HTML directly to backend responses. This reduces complexity, makes the code base more maintainable, and enhances responsiveness, as our interface stays updated in real time without page reloads. This setup ultimately delivers a seamless, highly interactive user experience. As a next step, we'll test additional groq endpoints with various prompts to observe the responses. These tests allow us to refine the RE's output based on prompt tuning and endpoint selection. Each query will return a prompt-based suggestion, helping demonstrate the flexibility of the application. With everything set up and tested, we push the first version of the project to GitHub. This project combines .NET Core, htmx, and Groq endpoints, creating a streamlined framework for building responsive and interactive applications. If you find this setup useful, don't forget to star the repository on GitHub. Thank you for joining today's session on setting up and deploying a .NET application with Groq endpoints integration. This approach combines AI-driven responses, minimal configuration, and continuous data streaming to build a robust application framework. Keep an eye out for future videos where we'll delve into further AI integration techniques and advanced features. Happy coding, and I'll see you next time.